Welcome to solverfy.
For this question, we have these null hypotheses. The null hypothesis is that the population proportion is 0.26, and the alternative hypothesis is that it is not 0.26. And we want to test these hypotheses at a significance level of 5%. To perform this test, we have a sample of size 809, which yielded a sample proportion of 0.24. The first question we are asked is, what are the critical values of Z for this test? Looking at the alternative hypothesis, it's a not equals hypothesis, which means that this is a two-tailed test. So there are two critical values, and they are given by plus or minus Z sub alpha over 2. And for this test, alpha is 0.05, so this is plus or minus Z sub 0.025, which means that our critical values are plus or minus 1.96. The second question is, what is the value of the test statistic? Now for this situation, our test statistic follows the standard normal distribution, and it's given by this formula. It's the sample proportion minus the null hypothesized proportion divided by the square root of the null hypothesized proportion times 1 minus this proportion over the sample size. So this gives us the following. And this comes out to minus 1.30 approximately. Rounded to 3 decimal places, this is going to be minus 1.297. And the third question is for the p-value. Now again, since this is a two-tailed test, this tells us that the p-value is equal to the probability of having gotten a test statistic, at least as extreme as the one that we got, in either the negative or positive directions. So it's equal to the probability of a standard normal being less than or equal to minus 1.297 plus the probability of being at least as big as positive 1.297. And of course, due to the symmetry of the standard normal distribution, this is equal to 2 times the probability of being less than minus 1.297. And this comes out to approximately 0.1946. And the last question is, should we reject or fail to reject the null hypothesis? And we can easily determine this by comparing either our test statistic to the critical values. Our test statistic is not more extreme than either of these values. So minus 1.297 is not more negative than minus 1.96, which tells us that we fail to reject the null hypothesis. And the other way is to compare the p-value to the significance level. Recall that the significance level was 5%, or 0.05, and the p-value is not smaller than the significance level, and therefore we fail to reject the null hypothesis.